Wow, I've got to say, I'm starting to feel like a mad professor. With all this stuff, it's getting a bit mental! Welcome aboard for another, probably one of the last tech vids. I keep saying this every time, but it's time for one of the last tech vids. And a little bleep there as the dashboard is switched on, and I've just brought my mobile phone into the unit, into the workshop, and it's locking onto the Bluetooth. So I'm just going to turn that off. It keeps reconnecting up. We've got the gearbox down here. We've got it, part of the wiring, part of this, the final tech stuff, before we go on to episode 34, if we're indeed not in it, is to get the loom connected up to the gearbox and get it talking to the various parts in the car. You saw me just doing that speed controller there, which works well. By the way, we've also got a Granada fuel computer which we can use to check the speed, because this does display the speed, and we've worked out the wiring on it. So if I hook the Granada fuel computer up to the loom, just the speed input to it, a couple of grounds, positive feed, and the speed input, I can see what speed my little torque converter lockup box cuts in and out at, and it's probably going to be about the speeds we thought, because I've just mocked this up on the bench, and the signals on the square wave generator around that band there is 28 to 60, so, and that's what it was showing. It's not going to be exact, but it's okay, because we don't need an exact switch speed for that. But what we do need is all the connections to the gearbox. So what we got on the A4 gearbox then, we've got a kickdown solenoid. I talked about this kickdown solenoid, didn't I? Let's get the torch on it so you're well lit. And we talked about this kickdown solenoid. That needs 3 wires. The plug I've got here is obviously not for it, because that's only got 2 wires. There's 3 cables on it. One's a ground, common to both coils. There's 2 windings in it. We've got the common winding, then 2 coil feeds. One's the low current, one's the high current. I've explained this, but the high current one does the majority of the work. So look, it's a lever that pulls on the kickdown arm here. You can just see it. So it needs quite a lot of force to get it across, but doesn't need much force to hold it. Now if you held it on the main winding, so if you just had 2 wires for this, ground and 12, as you held your foot on the kickdown, this would get hot after 20 seconds or so, and they didn't want that. So what they do is, there's a little relay called the Kickdown Relay. It's coming up in my left hand now. Here we are for Kickdown Relay. All the relay does is momentarily pulls the main winding, and then the relay flips inside and switches across to the lower winding, the lower current winding. So this relay just is a timer. As you press your throttle switch, which will be fitting on the accelerator pedal, the relay clicks across briefly on the main current and drops back across and holds on the holding current, so this doesn't get hot if you kept your foot permanently down. So that's got to hook up to that. That'll be up in the car. We need a multi-plug that's got 3 wires on it. Now this one here, this wiring harness, we've got various different ones we've been looking and dragging around, but we don't seem to have a 3-pin plug, but we can make our own by taking this plug off. And we have got various 3-pin plugs here which we could use and solder in, so I'm going to have to solder my own kickdown. This is an early kickdown solenoid. I don't know why they've changed it, but that's the way that it is. And we can just make the plug for that. So we'll make a plug for that. The trickiest bit, I suppose, was the what you call the lockup solenoid hookup connector on this box, this mid-range A4LDe smaller E box, or is it the capital E? Two types of electronic A4. There is a very early A4 box which is fully hydraulically controlled, and you don't have any solenoids to activate the torque lockup or the fourth gear. This gearbox you're looking at here that's going in Project Bramble is a gearbox that has the torque lockup controlled by two wires, 12 volts to it, activates a little solenoid inside, and that activates fluid into the torque lockup. Later boxes not only had that, but then they had the fourth gear controlled by the computer as well, which gave a bit more flexibility and probably gave you a sport mode. It would change up late on the fourth gear depending on certain characteristics, and that was in the Scorpios, the Granada Scorpios, and probably other vehicles. It's a common box. So that had 3 wires instead of 2. This plug here has only got 2. Most of the boxes that I've come across have got the 3 wire, so most of the boxes I've seen are later boxes. Consequently, I've got a lot of later looms hanging around and no loom with just a 2-pin. So I'm going to make a connector for it. It's small blade Lucas. Then we're going to plug that in. I've heat shrinked and soldered onto this plug, put 2 little blades on the end. I'm going to slot that into there. Then I'm going to use some Pegantanki, I can never pronounce it. It's basically an epoxy resin, and we're going to mix it. Once I plug that in there, I'm going to pour resin in it and seal it so that becomes the actual plug. You could take this gearbox apart and get this socket out and fit a 3-pin one and just use 2 of the wires, because we've got 3-pin connectors here, but I'm going to do it this way. I'm going to seal that in, so that would give us that hookup point. The park inhibit and reverse light switch, that has a common, then out it goes on 2 pins, gives a signal for either inhibits, or I'll have to just meter it out now and see what it actually does. I can't remember whether it's 12 and then you get 2 12 outs, or whether it's ground and you get 2 grounds out. Probably 2 grounds out, I would have thought. But having said that, this is switching the reverse light, so it's going to be positive in. Seems a bit strange, there's only 3 pins on there and it's doing 2 jobs. I'm wondering if it just controls inhibit relays. I'll check in a sec with that. The sensor at the back, we're okay because we've got the right plug for that. So we're going to build a mini harness here, all terminating in a multi-plug. So we've got to do our usual cable joins and tidy all this mess up, because if you ever got to take the gearbox out, you just want to be able to unplug one plug and drop the whole box. You don't want to be getting any gearbox shops messing around with all your cables. Just unplug one plug, let life go easier for them. So thinking ahead, it just wants to be on a one quick release plug. So there's the quick release plug, and it is the right one, or rather it's one that's intended for that quick release. This is a gearbox quick release plug, but of course this loom isn't quite plug and play onto this. For that reason, that connector's different. This is earlier box. Kickdown, solenoid, slightly different, earlier box again. VSS is the same, so we can keep that. So just going to make up a loom. I won't film much of that, except to say, you know, I'm going to seal this in and make my own flexi plug on there. So just to get everything going, and then once we've done that, we extend these cables. We need to make it so that the gearbox is obviously situated around here on the transmission tunnel. We've got to make that cable's got to be able to pass through a hole in the transmission tunnel, so that cable itself won't pass through the hole. You'd never get this. You'd have to drill a big hole in your transmission tunnel to do that. We don't want to do that. We want a hole about the same size as a diameter of the bunch of cables. So we can't put a connector on this because it won't pass through. So we've got to make it so that it's joinable without actually soldering. So I'm going to use small bullet connectors staggered, and then we'll just pass them through and then rejoin and then seal that with tape once it's done. So that's going to be after, you know, as they pass through the hole in the transmission tunnel to make that connection into the loom. So we've got to build the loom with not only that plug in it, but with staggered bullet plugs so that we can get these cables individually passed through the hole, and the whole thing's just one, and just stagger them. It's about the only way I could do it. The other way, you could just cut it, pass it through, then heat shrink and solder once it's in the car. That's another way of doing it. Just basically what I'm saying is I can't pass that plug through. The transmission tunnel plug's too big. I'd have to drill a bigger hole. I don't want to do that. I mean a big hole, big grommet. Rather just have a thin hole or small diameter hole and then join the cables up, either with bullet connectors or solder. We'll see. So that's all we've got to do for the gearbox. Electronically for the hookup connection. That gets another wiring job out of the way because there's loads to do. You keep thinking you've got there. You do the parrot Bluetooth, you do the torque lockup converter, you do all these things, and then there's still more and more wiring all the time. It's taking a lot longer than I thought. There's a lot more cables, and I haven't even got to the engine bay yet. So a long way to go, and this does feel like a long road at the moment, I must admit. Feeling a long road here, and I've seemed like I've been on this soldering now for weeks, and actually I have. Right, I'm going to build this loom up now. Okay, I've got the plug in there. I've not sealed it in yet. I'm just testing that the solenoid works. You'll hear a click as I connect 12 volts to the solenoid. Just have a listen. Stepping back, trying to keep you back, trying to keep you framed. And no click. Oh, wrong connector, sorry. Here we go. Can you hear that? So we know we're working. Now you've got to get the plug the right way round. And rhyming it for you. Ground the right way round. Ground to the right of the plug. Has to be that way because they've got a diode inside there. I didn't know that they had one, but I just thought as I was putting it on, I thought, I wonder if they have dioded this up, because quite often they do that on the coils to stop high voltage when the coil's engaging, and it stops, helps with radio interference and stuff. So inside the coil, probably, I've not took one apart and had a close look, although I have got gearboxes in bits, I could go and do that. But inside the body of the A4 gearbox, the little energizing coil you just heard clicking has a little suppressor on it, which means that it has to be the right polarity. So ground has got to be the correct way. Now I wasn't sure which way it was. Even when I metered out, I wasn't getting a diode coming up on the meter on Diode Test. I don't know why. I'll just double check that because it should do. However, I've got a very low voltage power supply which doesn't damage things. Here it is on the bench coming across. This isn't the main power supply. This is a little baby power pack, and it's only about an amp output, and it's got a short circuit protect on it. So rather than risk damaging the coil, that power supply isn't enough to damage the diode, because on a diode, if I connect 12 the wrong way round or the right way round, depends what you're using the diode for, but a diode can be short one way and positive and negative on the other side of the diode is open circuit. So if you put your power to the coil and the coil's got a diode on, and you get your power leads the opposite polarity, the diode creates a dead short. If you used a car battery to test this and you had that dead short, it would blow the coil up inside the box. So to be safe, I used a low power pack with a cut-off on it, and if I got it the wrong way round, it kills the power pack straight away without doing any damage, and it actually did do that. Luckily brown is earth. Could have been, it was a 50-50 chance which way round these went. Now I'll double check that you can't diode these out. Diode check these out with your meter. You have what's called Diode Test on your meter there. Look at it. If you ever got a meter and you wonder what it is, when you put these test probes across a diode and you have it on that setting, you should get around 0.6, 0.7 reading on here, which is the volt drop across a diode. The other way round, you'd get a reading of nothing, and that's how you can check whether diodes have gone short circuit. You get your probes and you just place them across one way across the diode. It should be open circuit. Swap your leads and you should get around 0.6, 0.7. Depends on the type of diode, but most diodes 0.6, 0.7, and that shows you that they're getting the correct volt drop across it. Diodes have that volt drop across there. So I looked for that initially, didn't see it, so I thought, I wonder if it has a diode or not. Connected the leads up, it shorted out. It used the low power transformer, by the way, not the main leads, and it didn't click and the power supply dropped off. Put it the other way round with the earth on there now, and you hear that click, so we know we've got it right. And I'm almost sure there's a diode in there. There's nothing else that can create that short the other way round. So that's an interesting little thing. Just refresh my memory on that one. Here now with the plug, we can fill this with the little resin and just pack it in there like that. See, I'll bring you in with a lamp on the plug and I'll show you what we've done. Grabbing my little handy light so you can get in and have a nice see. Alright, so that's it. We want to make that waterproof because that could fill with water there, in theory. And as I say, we haven't got them plugs. They're hard to find those, just a 2-pin version. There plenty of 3-pin versions around I've got, but because most gearboxes you can get your hands on happen to be the 3-pin later gearbox where that 3rd pin controls the overdrive solenoid. Another solenoid that clicks just like that one that you've heard, but this time engages the 4th gear of the box. It's possible to use the later box in your car, but you'd have to build an electronic controller to bring your 4th gear in. Anyway, that's a little thing on the plug and the solenoid for the torque converter lockup. And now we'll go ahead and seal that plug, and then we'll start making the loom for this box. This is the resin I'm using for sealing the plug into the gearbox. 50-50 mix. Needs to be a little bit warm. This was around 17 degrees centigrade, the garage temp, and it was a little bit thick, but just had the heat gun on it and it just thins it out a little bit. So a 50-50 mix on that. I'm just going to put it into that plug and seal the plug in. So Pega Tanky, it's good stuff. There's other stuff available, but this I got it picked up from the motor factors. So I'll give it a try. I've used it on a few repairs now. It's pretty tough stuff. Right, I'm going to mix that, a little bit of heat on it just to thin it out. It's got 8-hour cure time, this, a bit slow cure time, but for this plug it doesn't matter. So I'll stick this in now. Okay, lots to do as we look at you up there on the tripod. Down here then, doing the loom. Let's get down on the floor into this. Can you still hear me up there? Okay, we've got the speed sensor. We've got the park switch, the reverse switch. We've got the 3 wires for the kickdown solenoid. There's kickdown. Click, click. There's our torque lockup plug with that resin curing nicely. So we've got a multi-plug there, which is the main one out. So if you're taking a gearbox off, they'd pull on this plug. It's quite tough. You want some WD and a little bit of grease to get this plug to unplug. Wow, that's tight. It's going to go though. We just know it is. It's just wants a little help. Wow, that is tight. So WD is ready. It's going to go. It's going to be tough. Let's knock the music down a bit, I think. Oh, got ya! Woo! Wow! Give me some of that, baby! Woo! 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 Naughty, naughty plug! Alright, put that in again just for now. I've got to meter out these cables. Hang on. I've got to meter out these cables here to find which wire is going to where, and we're well on the way with that, so we're okay there. But what we need to do, some cables aren't needed, that one's not needed, that one's not needed. This one here, we've got to change the plug type. We've got, is it on the bench or is it down? Here it is. We've just got to change the end of the plug connector on the kickdown. This loom has a different kickdown plug, but we're using this kickdown, so I'm just going to use our solder crimps and we're going to pop this plug on the end of there with some heat shrink. So I'm just getting the right size heat shrink for the job. Various sizes to pick from. Looks like this one's favourite. adhesive lined, nice and waterproof. Over that would go. So I want a piece of heat shrink here. Preload that onto there so we don't forget to put it on. Right way to the end. That gives us these 3 connections here now. It's going to be tight because we're using those solder ones, and it's going to try and get the heat shrink to form in a place I don't want. Tough little cables these are. A heat-proof insulation they've used on these. Good job on your flexible friend. Nice working on the floor. Hope you can still hear me out there. I'm just getting these connections all ready so that we've got all the right fixtures and fittings. Grabbing across to find my joining pack. Here's my joining pack. We're going to use our super duper solder free, well not solder free but heat shrink free connectors. Pick your weapon of choice. I think these ones may just go in very nicely. Oh, look. That's what I'm telling you about. These lovely beauties make such an easy job and a neat job of adapting our cable socket end for this type of master loom that we've got here. Okay, I'm going to just take you slightly back a little bit so that the camera doesn't chop off my head. Hold on a second. I'll just keep you on. You may as well stay on. There's no point messing around. So, if I can get... I'm even further away. Stop it! That's better. Oh my God, what was I thinking? Right. Okay. Okay. Wilson! Right. Wilson! Look, I love these connectors! Okay. There's nearly hundreds of them. I'm going crazy now. This is definitely the fine line between the madman. Oh, can you please order millions of those for your toolkit, please? All we need, grabbing it just off your screen. Lock and load. We're going to make such a lovely job. They're so good, right? And I'm so pleased with these that I'm going to bring you right down in to the action so we can watch the solder. It's so relaxing. It just melts. Feel all the problems just melting away as we solder down here, and everyone goes, what the hell's he going on about? Come on. Right. Slide the 2 pieces together. Get your ink gun. Now they're very good, but just for a double measure I've put some cloth tape round those because they're going to be squashed together quite tight, and just in case, I mean they are good, but I didn't want to short there. So now I can slide, just about get this heat shrink to slide over, and then that plug is now converted from the old style to the new style plug, which then fits on the new style loom that we've got for this, because we didn't have an old style loom, so that's the reason why that's getting converted, of course, and we didn't have the plug for that, which is why we made that adapter. So I'm going to join this into the loom too. I've worked out the wires for the reverse and park switch. Park, grounds, there's a 3-pin switch on these. Park is the far one toward the tail shaft. That goes to ground when it's in park, and then the other 2 contacts on it's 3 pins. One grounds into the chassis when it's in park. The other 2 are isolated completely. They form the reverse switch, which is a positive signal in and out. So it's that end pin is the ground. It gets grounded to the casing once it's in park, so you'd have to adapt that now into a relay so that it isolates my starter switch, so I can't start the car when it's in park. Now that, because it's a grounded signal and my starter uses a 12-volt solenoid pulse, as all cars do, Ford on this would have had an inhibit relay, so this goes to an inhibit relay, and then the other 2 can go straight through the reverse circuit with no electronics needed, a straight hookup. This needs the kickdown relay. Talked about the kickdown relay there, that has to interface into this. So ground for the kickdown relay, a trigger for it off your accelerator pedal to tell it to fire up, 12 volts in and 2 12-volt signals out. As soon as I hit the accelerator pedal, this goes, this main current one goes 12 volts for just half a second. Then this one, a secondary winding for the kickdown, goes live, and it then disconnects the main primary winding, the heavy winding, therefore leaving it parked with just a light loading holding it in place. Now this just goes click click quite quickly. It's a simple timing kickdown relay. So that goes, but we're fitting that in the car, but we do have to trace the wires for the for the kickdown and find them coming out of the loom, because this is going to be inside the car, this loom, or almost inside the car, and we're going to be extending all of these cables. So I'm going along and writing these down as I go, so then we've got just one plug. So as explained at the gearbox shop, one plug, the whole box is disconnected from the car, no fiddly wires. That's what we're on with. So I'm going to slide this heat shrink over here and wrap it up, and that's that. Then obviously this has to be taken off and cleaned because it's grubby. A few other things have to be cleaned and detailed on this. Nothing major, but we will go a little bit of cleaning and detailing on the ancillary items of the gearbox. Got a floor pan, a sump pan that's been zinc coated, that gets put on. This is just to keep it covered. A couple of tidy ups, they just spray it in silver, you know what they're like. They're good. They're not doing concourse gearbox repairs, are they? You know, the internals are all mint and all refurbished. It's just that you've got to do your detail. You'd be paying a lot more to get them to detail all that. Soldering heat shrink time now. Gearbox then, gearbox multi-loom connector going on in this tech vid. Okay, I thought I'd just show you the kickdown relay. So kickdown's on, wiring loom is connected, heat shrinked up, end of the loom comes out just down here, kickdown relay's fitted there, so you've got a ground to the kickdown relay, a main power feed to it, so that'll be fused, then you've got one of the windings going to it and the other winding going to it, so the heavy winding there on the relay and the light holding current winding there, then one spare cable, and that goes straight to your kickdown switch. If I put 12 volts to this, it'll kick down. You can just hear the relay do its second click. I don't know if you can quite get that, but the relay does one click or a delayed click, a click on and a click off. Just have a listen. You can just hear it after the main solenoid's fired. Listen out for the relay. Just about hear it, and this is the end result. holding there now. And you might think, well, what's it all about really? Well, as I said, it takes quite a lot of effort to energize this. Now you might want to hold your kickdown on for a while. It's got to be foolproof. Someone could have the foot to the floor for, you know, a minute. Well, if you was to hold this for a minute, it'd get red hot. So to stop it getting red hot, what they do is the main winding pulls it in. That takes most of the energy. Then it only needs a little bit of energy to just keep it held. So they flip the power to a lower energy coil. They take the big energy coil out of the equation and instantly flip it onto a sort of lower or higher resistance winding in here, which doesn't take as much power. That second coil would never initially be able to draw it in. It wouldn't have enough power, but it's got enough to hold it. This relay does the job of just switching those two as you hit the kickdown switch on your accelerator. We'll have to fit one. That's all it does. In fact, you can prove the point, because if I hold it on, keep it held down. Now if I disconnect the main winding, you'll see that the kickdown does not disengage. Just breaking it now. It still holds. So it's holding on just that light green one now, so hardly using any power, it's holding it and not getting hot. Break the green power and it'll come off. So that's it. That is the kickdown done. Yeah, it's on to more soldering now. I'm taking no chances with these plug connectors, so in we go with some grease right onto that plug. There are different types of automotive plug, and some are better water sealed or designed to be completely watertight than others. This one, with it not being standard, we don't want to take any chances, so we grease that up. I'm sure these are well waterproof, but again, we'll grease those up. So we've heat shrunk on the connector, the new connector for this. That can slide into there. Locked and loaded. That's part of the loom. Just a bit of tidying up now on these junctions, and we're in. Everything terminating at the end of the loom just here. And I've labelled and marked everything now, so we know all those cables. And now we can start to connect it into the main dash harness and test everything. Get the kickdown switch working. While we've not got it mounted on the accelerator yet, we can just press the switch on the bench and we should see this kick in. Get a feed and supply to this. Can test the reverse lights and things like that, and just put a power to the solenoid and hear it click. We can also spin up the vehicle speed sensor. There it is at the back, and make sure that's giving us a signal. Test everything, and then we've done this section. That's great. We can wheel that back under the bench, knowing that all we've got to do is make that one connection. Of course, I have to feed these through the transmission tunnel at a later point, so these will have little bullet connectors on, so you individually poke each wire through, connect the bullet, then the next one, so you can actually get all that bunch through, because obviously, as I said, I can't pass that through the bulkhead. Not the bulkhead, I mean the transmission tunnel aperture. The hole for the transmission tunnel wiring harness on the Cortina is about this thickness, so we'll get that through. We have to enlarge it a little bit, but I didn't want to have a big hole there for this plug to go in. That's why we just bullet these up. Get in there now. Hey up, I can't move, fuck cables. Help me. I think I'm melting. There's soldering going on, there's wiring looms being built. I'm just doing some Molex plugs here, crimp and soldering my Molex ends on to make a multi-plug. It's an early start today, we're at 9 o'clock. Straight out of bed, straight onto the car for New Year's Eve fun. Gotta go out later, it's gotta be done. But we're ahead of the game. So, because domestically we're ahead of the game. Gives us time to sneak out into the shed and solder some Molexes, crimp, and just let the solder just flow into the little crimpy end bit, and find the other bit of the plug it all together. This particular plug I'm doing now, you can just about see it, can't you? Snapping together there, look for Molex, boom, 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 is the frost module, which we've now got. I'll show you that in a sec. Just sticking the Molexes in. What we want to do is, the last of the modules, the last of the international famous Playboys, the last of the famous international Playboys, last of the wires. We don't need our helping hands now. These are great. Get some. You know, it makes sense to get some helping hands. Different types of cutters. Different types of cutters. Oh yes, these essential tools review, guys. Yeah, what? Also wire strippers. Clark ones have done well so far. Good solder. This was 12 volt Planet supply. Obviously other suppliers available, but I've just got it in with my mixed pack of goodies and plugs and stuff. Just thought maybe just give them the whole order. Leaded solder. Don't forget as well, we've got that multi-position switch. Hear this. Now hear this. Now hear this. That's for the intermittent wiper 5 position setting for the interval on the intermittent wipers. 1, 2, 3, 4, 5. So we've got to build that up. At the moment it's got a variable one. We don't want that. We want a clicky one. Just going on the column. The steering column comes down just to my left. We have this, cut the shaft down here, and we make that nice little, here's the word again, knob on the end. And don't resort to cheap frill jokes about knobs, because they're easy, them jokes. It's gutter press. Right, now think of more sophisticated jokes, please. Right, okay, well, also I'm just going all over the place at a sec because my brain's firing on all the neurons. A isolate switch for the torque converter lockup, in case there was any reason when we don't want it on, and also any reason if we want it on all the time. We're going to make a 3 position switch and fit it just under here. We could fit a sport button by the centre console if we want. I'm going to include the wires for it so that you can, under certain circumstances, force the lockup on. I seem to think that there's a reason why that can be handy. It might be for towing, not that I'm ever going to be towing, but it could be a sport option. There may be positions where it's advantageous to force on the lock converter. It's an interesting option. I'll look into it just in case. So I'm going to allow that wire to be floating around the centre console, whereby if you connect 12 to it, it'll put the lockup on burning condition, other than brakes on, by the way. We'll include that cable. I must remember to include that cable now. Before we do that, I want to get the frost unit in. Now we've got the box for it. I'll show you the unit in a sec. I'm just going to thread the cables into the box. Little project boxes that you get from your wholesalers. I get all my electronic stuff from a company called CPC Farnell. They're in Lancashire, but they are online. Will that hole be enough for all 3 cables? No. Slightly larger hole required for the project box cabling hole. Enlarge that out, keep your hand out of the way. Bang, boom, boom. 3 cables to go through. Going to bring the angle of the camera down, watching you, watching me, just so that I don't have to keep offering up the camera. Hold on, let's get you in. Let's get you down. There we go. Easier on your eyes now. Pull that through. It's what we're going to do. Right, module, I talked about it, off the shelf, already built. Okay, right, we can get an LM341. Is it 341? 741? What do we do? What's our little thermistor? And we can build a little circuit board, and we can mess about with a little bit of ice and set the circuit board to click a relay when it's 0 degrees outside, as per Ford spec on the Granada. Granada switched in at 2 degrees on orange amber frost lamp, and then red frost lamp at 0. We've only got a single stage, so we're going in at 0. So we can build a circuit and we can try and cram it into this little box. Or for blooming £3, you can just buy one already done. I couldn't get the relay for £1.75. Someone's already gone and built that in China. And I'm thinking, yeah, let's impress ourselves, let's build our own. There's actually no point. It's an off-the-shelf item, programmable to any temperature that we want. So we'll set this for 0 degrees, come to the thermistor, dip that in a jar of ice later, relay will click in, and these wires are already loomed up and connected into the multifunction warning lamp. If you've not seen the other tech videos, you need to see them, because we've got a cluster light of 4 LEDs, 5 LEDs, orange, yellow, red, blue and green. Green is the LED that will cycle off and on when this hits 0, so when we hit frost. The frost sensor itself will go outside, it's going to go through the A panel down into the passenger side wheel well and along and come out of the indicator at the front of the car. So we get it off the shelf because there's no point spending a few hours building up a circuit myself when it's already available. It's just pointless. Too good, really, too good. But it connects into the cluster light. The cluster light also has the oil light, it has the over temperature light, low fuel and Bluetooth, and it cycles round. So if all the sensors are on at once, the oil would always take priority and flash the most, but it cycles round in this little lamp. We'll show it you if you've not seen the other videos. It's one single lamp on the dash. Instead of having all the different lamps for different sensors, it's just all the lamps in one cluster, all different coloured, but can never light up all at once because the circuit I've built cycles them round, and it takes the most maximum important ones as a priority. So frost is actually classed as mid priority. Bluetooth's the last one, because Bluetooth is a little blue indicator that lets me know I've not hung the phone, or lets me know that the phone's in progress, call's in progress. It's handy because sometimes the parrot locks out, or sometimes you've got a permanent Bluetooth established and you want to know that that's active. Bluetooth module, parrot hands-free just under there. All the wiring at the moment looks a mess. Well, I say all of it, no it doesn't, because I've made a very neat job of the cable, but around this area here and here and here, all this, whoops, there goes some cloth tape, is all over the place. Because remember, we were building this umbilical cord, get it right, for the gearbox, and we've built it, we've labelled it and built it. One cord for the whole box, doing kickdown, doing lockup, doing speed sensor, doing reverse, doing park inhibit switch park inhibit switch. So what happens is, as you're building that, you've got to make sure that to take advantage of the loom that you're building, that there's any other cables that may be needed to be wrapped in that loom at the same time, so you don't get wires tagged on top. You've forgotten to put a cable in for the frost sensor, for example, and you've already wire loomed your harness, then you've got this wire tacked on top. It's not as good. Now that will happen because there's no way I've covered every single cable that I need. There's bound to be something extra later, but we're going to have covered the most of it. Frost sensor then on the Molex, in it goes, quite simply, 12 volts to it and 12 volt output when it goes to 0, to ice, or whatever I set it on. I'm going to set it on either 1 degree or 0. And there's the 12 volt feed, and the green wire is the output into the Molex. The output wire of it comes out down where the centre console is, because that's where we hook into the multifunction warning inputs there. So we're now starting to form the harnesses. Here's that torque lockup box that we did on the previous film. You can see how the looms start to take shape. and you plan them out. Everything's going to be hanging around this side of the dash. That's the passenger side. There's still plenty of room. We've gone to another Cortina because we happen to own a few, and felt underneath and gone under with a torch and looked under the dash at everything crammed in to see where places are where you can hook modules. And with 2 screws, 4 screws I think, and a little catch, the glove box pops out and you get your hands in and all your modules are fitted there. Everything's individually fused, of course, and we've made notes after we've gone along to where things are. Although we must make a proper chart on the computer. I've started that as part of my homework. It has begun. So that's it. Each relay and each module is labelled or marked up with Paul's super duper pens that he supplies us. Paul Underground. And then, yeah, we just make the final connections. Here's one connection to finalise. This is the actual lockup output relay. And there's the pink cable which goes all the way down to the gearbox. You can see the pink running down into the gearbox to actually hit that solenoid that we just repaired the plug on with the Pegatanki glue, which has now gone nice and solid. So that's what we're up to. All looks all chaotic. Hold on a minute, let's be chaotic. It'll soon tidy up. The main thing is that you make your notes and don't forget what you've done. Some wires go across here to pick up the brake pedal for the lockup, to kill the lockup. A couple more wires. There's a blue wire here which is the inhibit wire coming off the gearbox again. That blue inhibit wire connects to the starter inhibit relay, which is also part of the alarm system, so that connects into the alarm. So all sorts of things. The vehicle speed wires now all 3 join up because you've got the output of the speed sensor there going straight to the box. You've got speed sensor input for our lockup controller so that it can switch on at the right speed for the lockup output. And also another speed sensor wire goes down here to join to these 2 for the cruise input, cruise module just up top. You can just see the module just there. It's not actually fitting there at that angle, it twists around. So that's it. We've also got a diagnostic port for the VSS, which you can either inject the signal in, or we can, in our case, we're going to put the signal into the actual gearbox end, which will test the continuity of the speed signal all the way through into the cruise and the lockup box. And in that case, if we do that, we fit, this plug becomes an LED which will flicker as I either spin the shaft sensor. What should happen is the LED will plug in here. There's 2 types of plug basically. Let's get this straight so you understand. 2 types of plug can go into the diagnostic port here. One with an LED on the end, which will just show, it will light up red, and as I turn the gearbox propeller shaft, this will just do the little pulses as it, and that will tell us the prop sensors, what the speed sensor at the end of the gearbox is actually running, because it's showing it getting it into the loom. If you want to diagnose the car and the gearbox is fitted already and you've got a fault with your cruise or your lockup and you're wondering if it is the speed sensor, this ain't flashing. To test the system, a different plug, but this time on the end of it would be the signal generator, and you can inject the signal into the loom from this plug as well, so it'll do both jobs. And then I can force the cruise on by injecting the speed sensor signal into here. So in other words, I can test the cruise while the car's stood still. It doesn't have to be running to spin the speed sensor on the end of the gearbox. So that's a way of testing the cruise while you're stationary. So that would be, for example, if I'm mounting it somewhere and I want to get the noise levels right, or I'm listening in the cab to see if it's noisy, because we don't exactly know the position of the vacuum motor that fits, boom, on the cruise. So there's a couple of things for you. Sorry that I'm talking a bit quick, but whenever I'm wiring up, I'm in hyper mode. I'm going to actually connect the frost sensor in now and actually have it running, just so that I know I've got 12 volts coming down the line and stuff like that. So I'll strip the wires, we'll fit this in, I'll give it a bit of a tidy up, then we'll come in a bit closer. You saw me doing the Molexes, and then we'll test all the systems. We should be able to press the kickdown switch, which I've got hanging around. I've just wired a micro switch to it. Here's our kickdown switch. Okay, we should be able to press that and hear the kickdown. We should be able to put the diagnostic LED on here, turn the tail shaft of the gearbox and watch the LED flash. We should be able to inject a signal into here from the square wave generator and get the torque converter lockup box to fire up at the appropriate speed. Then we should hear the solenoid in the gearbox click on for the lockup as this hits its correct speed on the simulator. So we'll be able to test what we've just done. We'll be able to put the gearbox into reverse, and I'll fit a buzzer so you can hear it audibly, because we've no reverse lights in the loom at the moment, but I'll fit a buzzer on. I've got a little handy little 12-volt buzzer knocking about. We'll just shove that into the loom. I'll put it into the very end of the loom, the actual loom where your reverse lights fit, not at an early stage. That way we know it's getting all the way to the end of the car, the tail end of the car. So we'll put it in reverse, we'll buzz. We'll then try and start the car. Again, we'll use the buzzer on the output of the starter motor in the loom in the engine bay. And then we shouldn't be able to start until the gearbox goes into its fully parked position and the immobiliser key's been activated. So that'll test the immobiliser and the park switch. So you're going to be hearing some buzzes, some clicks and a couple of flashing lights soon. Let me get that set up for you. Give me another hour on here, then we'll jump to it. This is the last of the exciting tech videos. Okay, let's do that now. And you can time jump. I'm going to have to do a bit of tidying up and wiring. Let's go. Wow, I've got to say, I'm starting to feel like a mad professor. With all this stuff, it's getting a bit mental. What can I say? Except I'm struggling for. I'm lost for words. Right, the umbilical cord is complete, and here it is. Just as we said, just one lovely cable to hang ourselves with. Am I building a rod for my back? I hope not. Have I got enough wire to... I can't take it anymore! Right, so everything's gone in. Let me just get the seat. Hopefully this seat keeps you at the right level. Boom! Right, an earth wire goes to the whole gearbox, okay? Just below me, down there, there's a bigger, well not a big earth lead, one of the croc clip leads, so we need to earth the gearbox because the kickdown solenoid gets its earth from the box. There is an earth strap on the box, and obviously it'll earth through the engine as well. We now have my professor time. Oh yeah. We've got the kickdown switch, here it is. So this will go on me, I'll make a bracket to fit this switch to the accelerator housing like I did on Ruby. So press, poof! And also there's the kickdown relay just there. I know things are miniature on your screen, sorry about that. I think you can see, sometimes when I'm filming it I'm looking at the screen, everything's minute, and when you put it on the big screen at home, hello big telly viewers, hello streamers to your telly on the wall, please put some comments in on YouTube now or on the live chat. How do you watch Cortina City? Is it streamed to the big telly? Is it on your phone? If it's on your phone, is that not too small on your phone? Let me know how you watch the experience, okay? And there shouldn't be too many ads as well. I've got to have some because YouTube doesn't pay much otherwise, but sometimes it throws on loads and I delete them off. I'm not trying to blitz you with them, but I've got to have some on. Right, watch. This goes, so that's good, and there's the kickdown relay just there, like I was saying. Also the kickdown relay stops you from whacking the hell out of the kickdown solenoid and making it become like a hammer. Look, you can't, it won't let you do anymore until you wait. And you can't actually do loads of clicks. Just one, and you can hold it down, that's fine. Hold it down as long as you want. What you can't do is abuse it and whack on your pedal. That's also what the relay does. So that's good, that's fitted. I'm going to hit the select switch off screen for you, but we're going to bring the camera down so that you can watch this happen. But we're going to go into reverse. I'm in park at the moment. that's reverse. Okay, so we're going to bring you down now and show you the gearbox, because there's some stuff I want to show you, and on the bench. So we're going to go handheld and handheld. Here we go. Right, let's talk through the systems. We know about this torque converter lockup. If you've not watched the video, it's the previous film. This is a box that we built to activate the torque converter lockup under certain speeds, or over a certain speed, and as long as you don't hit your brake pedal, which if you do hit your brake pedal, it cuts it out for 20 seconds and then reactivates it. I'll show you that now. I think I can do that. Let's have a look. We're just going to get a 12 volt to the pedal activating switch. It's in my left hand. I've got the wire for the pedal activating switch. I'm going to click it in, and look, and we've lost lockup, but lockup wait, so again you can't pulse the pedal and click this box and it cuts back in. So that's the pedal activator. We've got an indicator light for lockup here. That goes on the T-shifter stick selection area. I'll show you exactly what I mean. Over here we're going to start building it soon. Sorry about the mess. Look, this is the T activating shift. We're going to have the words TCL engraved in it and a little illuminating lamp, so that would go in there like that and tell us that TC is locked, torque converter is locked, so that tells us the box is working. Plenty of relays around. There's the actual torque converter lockup relay output. So any minute now, if I connect this, because it's locked up, if I connect this to the relay, we would get, you can't quite do it because the wire's not stripped back, we can just about do it, we'd get it to click in because that's on and live. I can't quite do it till I strip that wire, but that comes on, that pink wire, straight to the lockup. Okay, we've got a speed sensor. We can hook that up in a sec and check that that's working. But before we do, we've got our Granada fuel computer rigged up, indicating 45 mile an hour. Now that just takes the speed signal, which I'm injecting into the system at the moment. This is a diagnostic port for it. You can use that to connect either this up or the LED, which shows us the actual output of it. I'll show you the LED coming up to your screen from the left. This would go there to test this sensor. I'll show you that getting tested any second. Now at the moment it just so happens we had a fuel computer off of Granada. I worked out where the speed input was, connect 12 volts to it, and it just looks at the speed input. It's exactly 45 mile an hour. How about that? Because we guessed this, I had no idea. All over the years when I've been setting up the square wave, that halfway between the red marks I've put on, I expected to be 45, and it is. That's just coincidence. I would have thought, you know, lucky between 40 and 50, but it's actually bang on at 45. That's the average reading. It's held at that now. So torque converter lockup is in, at least at that speed. We're going to see at what point it drops out. I don't mind if it drops right out at 20 mile an hour. It doesn't matter. It won't stall the car. And even if it didn't drop out, you hit the brake and it'll cut it out. At least if you hold your foot on the brake. But it's going to cut out by the time the car stops, guaranteed. Also, that tells us what point the cruise is active. It's going to be again around 30 mile an hour. We can actually lock the cruise on with this test box, kill it off. So that's working at that speed. We can keep turning the speed down and find out at what point the cruise comes on and at what point this actually drops out. If I turn the speed down now over here, go across and turn down the speed, we'll get the Granada computer will start to show a slower speed, and the safety LED begins to light on the lockout box. Whether the cruise is still on, we don't know. There it is, so it's still happy at that. This is an average, so it's going to take a while to drop. We'll see what speed it drops to. There's the loom, then following it down across, look how it goes across to there. So we can neatly wrap that. Obviously it's going to have to be cut at some point to feed it through the bulkhead, then rejoin, but at least all the colours are all separate colours. There's two blacks, but the other black's marked with red pen. The rest are individual colours, so you don't have to work it out. It's going to go through. There's the brake active relay. That's what puts the delay into the lockup, the 20-second delay. When you hit the brake pedal, that's just wired straight across the brake pedal. Reverse works, kickdown's working. So that loom's ready to rock. Oh, we've got our temperature as well, look. Currently at 24 degrees, that's fitted into the, whoa! That's fitted into the box and into a nice Molex there for servicing if needed. So temperature then, you can just set, we've got it on 0.5, so I'll get some ice shortly and we'll hook it into the auxiliary warning lamp and we'll watch that go in some ice. There's the probe. We can extend the probe if we need to. It'll go wherever you want that probe. So that's it for that. Cruise is working. Speed's starting to come down, look now. But because it's an average, it takes a few minutes to lock it. You can't get instantaneous speed on the Granada computer. It's a shame that we haven't got a fuel flow sensor off a Granada carbureted engine, because if we did, we could connect that into the car and you'd actually have MPG straight up. So it might be worth us going to the scrapyard and trying to find a pulse output, pulse fuel flow pulse unit or a fuel flow meter and getting it hooked up. There's no point getting an off-the-shelf one. I have tried off-the-shelf ones, just curiosity on the bench earlier on, and they're specially configured for the Granada. You're not going to get, you'd have to build some kind of emulator. Could be done, but I don't want to spend heavy time on that. I've fed information into the fuel input of this and watched it read, and I've worked out it's between, I think it's 10 and 120 hertz. It's so many pulses per litre that it looks for, but you really need to have the right fuel flow sensor, one that's set, because otherwise it's just going to give you readings that are inaccurate. The whole point about MPG is it's bang on accurate, so there's no point me trying to just get something that's something like right, because the whole point of MPG is you're to 1 mile an hour of MPG, so we need to get that. I've googled the pumps up, and there doesn't seem to be much out there. There is a programmable pump out there that you can get and set it to how you want. And we could do this with experimentation and get that running. It's where I'd fit it though. I wouldn't want to see this computer anywhere visually in the car without lifting a lid. Could go in the centre console, but it'll take up most of the centre console storage space. Could go in the glove box perhaps, but I would use it as not to be looked at all the time, but something that you'd look at for reference, so you could from time to time see what your MPG is on the car. It'd be handy for that, but I don't think we could use it as a permanent display. The LCD readout there can't be extended really, because it's stuck straight to the circuit board, and there's a hell of a lot of minute tiny connections that are held on with like a rubber contact pad, and there's no way of really extending the display and bringing it into your car. You could hack into the electronics, but by the time you've done that, you may as well just start from scratch and build an MPG meter yourself. So there's two ways you could do it. You could just build your own with an Arduino, which we could do using the VSS speed input that we've got on board, and then getting an off-the-shelf cheapo fuel transducer, but it'd have to be the right type to measure the amount of flow that a Weber carburetor uses. A lot of fuel sensors usually work off quite a large flow. You need a precision one that won't stall and that can get past any vapour in the fuel, and that's the tricky part. Anyway, that's another thing. I don't want to concern myself with that. We've just used it for speed, just as a bit of a confirmation, because it's receiving exactly the same inputs that it would as if it was spinning on this gearbox here. Alright, so that's that. So we're getting down to 42 mile an hour now, and looks like it's steadied out there. The rest of the wiring harness now will begin to very quickly tidy up. To you, probably looks a mess. To me, I know what everything is. It's just a question now of routing the stuff, checking that everything's connected to the right fuses, and that this loom's all up and running. As I said, we've got reverse because the buzzer comes on. We just need to check the starter inhibit next. That's one of the last things to do. We can check that VSS. I'll show you the VSS now, although it will mess up the average speed reading, so really maybe we shouldn't. Let's just see what we've got on here. That's the MPG because it's receiving no signal. You can see the average MPG's down. That's when I was injecting it with fuel input signals. Started to drag that average down. That's our trip. If we reset that, that might give us something. I should be able to reset that. I don't know why I can't. Because that's our trip. Why can't we reset our trip? Not sure. Should be able to zero that. I would have thought that's your miles elapsed, and that you would want to do that. I wonder if you've got to do it under certain power conditions. I don't know. But that should go. There. I don't know how I did that. There we go. We're out. So that's our trip. Down to 41. As I say, the cruise is active at that. And are we still on? Yeah, we're still locked up at 41 on the torque converter. It's time now to turn. Can you do this while I'm on? I'm going to shuffle across the floor. Sorry, this is going to be a bit shaky. Just going to turn the speed down till it drops out the lockup. If I bring it in, rare use of the zoom on the LED for the lockup. Going to drop the speed. It's out. Lockup just dropped. I bet you the cruise won't run now either. Cruise might just hold. We'll see a big drop on this in a minute. Cruise is gone. So cruise and torque converter lockup are calibrated around the same area. Don't forget that I can adjust this. That's how I built it. So we can adjust the drop out or the drop in, the lock in point of the torque converter lockup. Torque converter lockup LED's gone out. And indeed, if we had that connected, we'll do that next. We'll finish off and connect this wire. That'll activate. You'll hear it lock up in the box. So we're going to do that next. We'll get this wire connected so we can listen to the lockup solenoid kicking in and out over here. I'll also connect the speed sensor and we'll check. We'll put the diagnostic lamp in. Take this off so the computer won't be on anymore. And this should flash as I turn the shaft of the gearbox. And all we've got to do is the park inhibit check. The wire's in for that, we just need to connect it to the inhibit relay. Going good though, and then we can now start to tidy up. Okay, that is 32 miles an hour, averaged out a little bit now, down over to the controller. So we know, I thought that was 30, so hey, not a bad guess. We've been setting up on the bench, just approximating it. Don't ask me how I did it, I've no idea, it's just luck. So we're going to move on now and do a few other tests on this. I'm going to show you the output from the VSS speed sender now. Round again we go. A lot of going round and around, isn't there? Okay, let's try it. Okay, checking the starter inhibit. We should get no start because we're in reverse at the moment. I took the buzzer off reverse. No start, no start. Immobiliser's on, but still no start. Go back on the selector, click, and boom. And we start. Therefore, selector is doing its job. So that's the selector done. Computer reboots. Okay. So we've still got the speed in. We've got torque converter lock is on. We're just about enough speed there. If I drop the speed, we'll lose the lockup. Just double checking that. Yeah, because we designed that to come in. Out it goes. I heard the gearbox solenoid click too, because the gearbox solenoid is now hooked into the system because that final wire is on the relay. So gearbox down there, the lockup solenoid pinged on because this relay came on, because this box said it was okay, and that was it. And it's dropped back out. We're going to drop it back in. Give it a click. Going across, increasing speed on the square wave. Up we go. Slight delay. on, and you heard the click closer to you, that's the gearbox click, and this relay click, whoops, and this relay click as well. So that system's okay. Double checking kick down, starter inhibit's going. Now for the speed sensor. Now it's time for you to go down there. Off the tripod you go. We readjust ourselves. Okay, for the purposes of testing with a square wave, we didn't want the speed connector in here because it would ground out our square wave from the bench signal, because that actually comes out on these cables. The whole system's live. All 3 speed inputs are all terminating here, and they're marked up. You can see VSS for cruise, VSS for the TLC lockup box, VSS straight from the box. That's the actual signal there from the box. We've injected the signal there, so we've overridden it all. We're going to leave these wires with a breakout connector on the end for diagnostic reasons, although we also have the same connector available to us just over here where the fuel computer is. But fuel computer is now going to disconnect. In fact, don't really need to disconnect the fuel computer, actually, it won't affect it. We just need to disconnect this, then connect. Oh yeah, we do need to disconnect the speed computer because I'm putting my diagnostic LED on there. Right, I'm going to put you back on the tripod, lower down, and we'll see this flash as I rotate slowly the output shaft of the gearbox with the speed sensor connected. That way we know the speed sensor is giving pulses and that they're reaching all the systems. We won't be able to get the lockup on because we won't be able to spin the shaft of the box fast enough, but we'll see it blink and recognise that the box is connected. Then we're almost done. All we've got to do is get some ice and check that, and connect the frost sensor, the black ice sensor, into the multifunction loom and watch that flash green. That is then about it. It will definitely be tidy up mode till we move to whatever we've got to do next, probably the centre gauges, but that'll be another day. So I'm going to wrap this, get the workshop tidied and finish early for the day, because it's New Year's Eve, I'm going out, so I want this all done by 3 o'clock. Gives me 45 minutes to go approximately. Let's check the motorcraft, the better parts. Alright, let's go. Motorcraft's slow actually. It's actually 25 past. Motorcraft needs adjusting. The bin wagons are outside. Sounds like Terminator 1. Beginner Terminator 1 when he hooks the bins up. Bin wagons. Whoa! Next door's wine bottles. Or are they mine? No, they're my Peroni bottles. Boom! And next door's wine bottles, probably. Yeah, it's all getting very robotic, this actually. It's not quite artificial intelligence. I don't know if Alexa would agree. What about getting an Alexa to run everything for me? And it really would be robotic, wouldn't it? I've got an idea. Hold on a minute, lads. I've got an idea. Clear the mess up first. Alexa, what's the laws of robotics?
Laws of robotics are a set of laws, rules, or principles which are intended as a fundamental framework to underpin the behavior of robots designed to have a degree of autonomy. Robots of this degree of complexity do not yet exist, but they have been widely anticipated in science fiction, films, and are a topic of active research and development in the fields of robotics and artificial intelligence.
Wow, right, okay. Hang on a minute. Well, we could get Alexa to open perhaps the sun. No, I haven't got a sunroof. Open the doors. Alexa, open the pod bay doors.
I'm sorry, Dave. I'm afraid I can't do that. I'm not Hal and we're not in space.
What about it responds to alien? Mother! No. Yeah, okay, Alexa would be good, wouldn't it? Let's get this hooked up and tested. I wonder how Alexa is for conversions. Alexa, convert 35 mile an hour to kilometres an hour.
35 miles per hour is 56.3 kilometres per hour.
Is it? Blow my neck, you're not wrong. Alexa, you're smart.
I try my best.
Nice, okay. Let's go. Come on, getting distracted. gearbox. Oh, isn't it looking neat though, folks? Yeah. We need a ramble, don't we? We need a little ramble. Yeah. Okay. Oh God, I think I'm melting again. C3PO, by the way. Here's an interesting one. Each 10 spacing, or each, sorry, not each 10 spacing, on each number spacing, 1.8 to 2, equates to 10 mile an hour. I've just been checking it. If you hit reset on the trip computer straight away, it gives you the instant readout. I forgot you could do that. So we can go up to 100. It definitely goes up to 90. That's 90. Full speed on my dial gives me, it was on 90 before, 98. Yes, right. Wow, I like stuff like that. So this should be, that should be 60. Roll with me. Should be 60 around that figure. 61. Oh yes, I do like it when things work as they should. It makes me very happy. Okay, that's good. Everything's going very nicely then. Everything's behaving as it should. All we're going to do is connect this up. I told you I'd do it. I'll put it on the tripod. Let's go. I just wanted to share that calibration information. How handy was it? Just as a great little reference tool to have that computer there. I just got it out when I'd scrapped the Granada and got the gearbox and bits out of it for Ruby, I think it was. Onto the tripod for you. One last check to make. Okay, join us then as I tilt you down this way. Hold on, making sure that everything's all right. I've just got to, I'm trying to make things good for you, you know. Right, I'm going to connect, hold on, disconnect the speed computer. I'm on wheels, so the whole bench just moved. Disconnect the input from the square wave generator. Connect. Oh, did you hear the gearbox drop out? Because I disconnected the speed input. Wow, torque locked up, dropped out. Connect the speed sensor on. Clip it in this lovely little clip that we've had galvanised. It makes it look nice and smart. Clips in really nicely there, look. Earth needs to stay on. Come here, gearbox. And now get me a little diagnostic LED, and I'll move you again. Now hook this into the loom, and then we'll spin this shaft here, and you'll see this blink, so we know that this is sending the info into the loom. And that's it, we're done. Right, move the angle of the tripod, hold on, have a look this way. Okay, so our diagnostic LED in there, which if we're on the road and we want to check our gearbox's outputting all right, this will just be dangling. It'll be just up there with a Velcro or a hook, and because we don't want it flashing all the time, annoying us. Or it could be in the glove box if you want it. There's nothing to stop that being in the glove box. But there it is, and you can see it's lit at the moment. Can you see it, that it's lit? I can't tell if you can tell. Yeah, I think you can, because cameras tend to pick up LEDs quite well. I noticed when I've been editing. It takes ages to edit these films as well. Can't see where that is. If not, I'll zoom in on it. And I'll try and angle it to where I think you're going to see it. Right, now behind me, I've got access to the shaft. We need to be out of park, or we can't rotate, we're out of park. So now, there we go, it's picking it up. Look, it's gone out. On as I do the rotation, look, pulses. We'll never get it fast enough to do anything. It should read it on this as well as a very faint pulse. Well, not a faint pulse, it's just that this needs stronger speed. There it is. So that's picking up as well. I mean, we could test it by just simply putting the drill on the sensor and spinning it up on the drill, and we'll hear everything kick in. We could also do that. So that's it. We don't need that on all the time. But I'll leave it on for now, so I don't lose it. We can get some ice now. We'll go and do the ice sensor, then it's a wrap for this tech film. We're probably into an hour now. So I would have thought I'd managed to rattle off another tech vid, but I guess we're getting closer to the end. It's been a long haul. I'm sorry, there's been about 5 or 6 tech vids. A long haul for you, and a test of your patience. And I know some of you are just classic welding car, actually more when the body shell's here of interest level. And this is can get quite repetitive, I suppose, because I've done 6 films. However, I think they've been interesting. A lot of people seem to like them, and we may have brought in a new whole set of tech fans in on board. And maybe I'm always going to do the odd tech vid to keep those fans happy as well. We could always do project building when the car's done, you never know, there's all sorts we can add to it. What about that Alexa system? That could be great. Certainly for the in-car cruising system, I'd like it to be as unobtrusive but functional. And I think Alexa, I've got to be careful here, because if you've got one, yours is going to be waiting. Oh, Alexa, you picked me up. Alexa, are you smart?
I try my best.
See, this is the problem. I might be setting your machines off. I'm sorry, but I only just realised. Oh dear. I won't do it very often. We get one of those X's. That doesn't pick it up. Yeah, we get an Exa, and then we could perhaps get it to control things. I would probably need it the most for organising hotels en route. So let's say, because I tend to do a heck of a lot of continental driving in this car, so I'd like to be, and I don't tend to plan. You'd think that I would plan, but holidays I don't plan. Tech stuff I do. If I do a trip to Scotland, for example, I'll just go the night before. I want to book anything, and I'd like to be on the road driving and just say, Exa, find me the nearest hotel, call the nearest hotel, set the sat nav for the nearest hotel, etc. Or what's the traffic like in the next hour on this road? That would be great, because me TomTom is a live one. It's all right for what it is, but I think that 40 quid a year for the subscription's an absolute rip-off. I'm definitely not doing that anymore. Not these days anyway. So wouldn't it be good if you could just have everything voice operated, and then it would do everything in the car. I mean, you could even, because the MP3's got Bluetooth, if I select the Bluetooth pair button on this, the dash light will come on as blue, and we know we're paired up. You could pair it to a smart device which Exa's connected already to. So Exa would then play via the smart device into this set. So if I had Spotify or whatever you need for Exa, is it Amazon Tunes? I suppose I would have to subscribe to that. But then you'd have access to even more music. So it's great that I've got my MP3 sticks, of course, and I've got a lot of music there. But it's a little bit limited with the MP3. It's great for what it is, but it'd be good if you just, because all of a sudden you might remember a song that you haven't got, and right at that moment in time you think this song would look good driving through these mountains. Exa, play this song, and it would be, obviously I had selected Bluetooth on my radio first and switched away from the MP3 system, and then I would be accessing the Amazon library via Exa, via my Bluetooth hookup. Should go through that module box, and I think that would be cool. And also hopefully you could just say book the nearest hotel, or call the nearest hotel, or check for availability. I think that is something I'd be really looking at doing. You know, we've got a lot of smart systems on here with the wipers and the automatic system, basic but smart. So that'd be good. I'd like to do that. But that's all nice. But remember what we said about keeping your point of focus controlled in these areas so that you don't drift, because otherwise the brain power you need, or the area you need in your head to get this finished, can get compromised by thinking away from something or getting distracted. So I tend to try and not do that. I might make a quick note of it, then look at it later on. Very important to stay focused and divide each job up into sections. We did that with the body shell, it worked. We've done that with the organisation of all the parts. Everything's landed at the right time. The last delivery of stuff's going to be the chrome any minute now. In January all the chrome arrives. The hydro dipping's already about to get delivered. Our front screen's being delivered. We've got the wheels done, interior's done. It's getting painted as we speak. So a lot's going on. All those, they're not even juggling balls really. I think that's the wrong analogy. They're cogs, and they're all turning. I've got a good analogy for you. Do you remember Connect 4? Maybe you've been playing it over the Christmas period. Connect 4, when all the counters suddenly go into the right positions and they all just go in and go down. That's how I see things. Look, turn these wheels, look. And the wires, turn these wheels and all the parts. Everything starts to slot together and form the little roots, and then it comes down to the finished product. And the bandwidth narrows. So when we first got the car, you've just got a rusty old car, and there's millions of directions it could go. You start taking it apart, and that's got to go to chrome, that's got to go to powder dipping, that's got to go. But as you get closer to the point, it starts to come in like this, because I'll tick the dashboard off, I'll tick the wheels off, I'll tick the interior off the list. So you start to zone in like that and get more focused and more focused. And then once you do that, you get more time available again to then re-hone everything and also get some organisation back on. So it's good. I think we've covered everything there for today. I can't see what else we've got except to tidy this mess up. Now you may say, or you may be concerned or inquisitive or commenting that this is all looking a mess. We're going to have to wire wrap it now. Alright, and I want to make sure we've got all the fuse numbers written down. But I think we're done. I'm pretty pleased with how that's worked. We won't cruise, I don't think. No, we're offline. Of course, we've disconnected the signal generator. So we need to make sure we mark that up. And that's a hookup point, as is that hookup point. Okay, I think I'll call it a day. What I'll do is give you one more clip with all this tied up, so a jump ahead in time for you. Okay, let's just see what time it is. Alexa, what's the time? Hey, no. Alexa, what's the time?
The time is 2:48 p.m.
We're running out of time. It's New Year's Eve. We've got to go. Hey, Alexa, Happy New Year.
Happy New Year. Wishing you a fantastic 2020.
Okay, here we are. We're doing the last test. It's the temperature probe, a glass of Jack Daniel's finest water. Oak aged over smoked-filled honey barrels. Right, okay, alright, let's have a look at this then. Right, that's a blooming good start there. So, we've got the start. Can you see just there a flashing red light? That's our oil, but it should also go green once we drop the probe into the ice. We've set it on 1/2 degree, so down we go. And it's going down. 0.5 to target. Boom! We're on. We should now get a green lamp following the red, just above my head, following the red. Do we get green for ice warning? Or is it a fail? No, we're on. There you go. Frost warning. Bring you in a bit closer. Okay, we're good to go. You're coming in close. You may as well stay on live. I did it before, no one moaned. Okay, so JD's finest. Ice melts at 0 degrees. Red for oil. Frost. And not only that, but if we switch our side lamps on, the oil does not dim but the green does. And we can adjust the level of the green dim down. At the moment I'd probably turn it down even more, but it does dim down, I can assure you that. Oh, I've not connected the dim down unit. Well, there's the dim down unit there. Whoops, hang on, let's connect it and check it. I thought it wasn't looking right. Okay, side lights on, and now we're dimmer. but not for oil. You don't want it for oil. Hold on, I'll try and get it to turn the lights off and on as we go. You'll see it dimming out. Couldn't quite do it. Does work though, I assure you that this cycle now will be on full brightness again. And that is it. Hold on, no, this cycle will be on full brightness. What am I talking about? Stay cool. Right, you saw that level of green. This will now be much brighter. There it is. So that's this little side light hookup just there. Has to tell the gauge, the auxiliary warning gauge system to dim down, and you can adjust each lamp's dim level as well. So because different LEDs, different characteristics. Same would apply to our low fuel because we don't want that bright as well. Okay, so there we go. That's how it works. Dead easy. Out of the ice we go. Climbing up and then it'll extinguish. End of. So that's, you can set the frost anywhere we want. So we can go 1 degree. We can go -1. I'll set it at 0.5. So once the outside air temperature is around 0.5, I'll get a warning about it, saying that ice is around the corner. And you can always call up the weather if you wanted on your Exa and ask her, or even my TomTom actually gives you local weather as well. So that would be a little warning for you and not too intrusive. That's it, all modules for today. Gotta call it a day. We're out of here. You saw everything working. Hope you enjoyed this tech vid. I said it was the last one last time. Over now. Happy New Year 2020. You'll be seeing this in the new year, so hope it went all right. You're in the future again. Thanks for the comments and subscriptions and the recent new Patreons as well. Welcome aboard. Good to see you on. Appreciate the support there. Helps keeping all this filming, because I normally wouldn't film this much, but then Patrons are out there and YouTubers also support me out there, which keeps everything going. I say this at the end of every film. You're going to say get the hell tidied up because it's a mess. And the next time you see this, it'll all be neat. See you in the new year, and over and out from Pete C. Cortina City, and of course Alexa. Hasta la vista. Should we do one more? Alexa, Happy New Year.
Happy New Year. Wishing you a fantastic 2020.